Hello aspirants, a very warm welcome to you all. My name is Madhusudan Reddy and I'll be teaching you the subject of geography. And in today's session, we are going to cover in a detailed manner with respect to the interior of the earth. As you all know that in the day one itself, I've told you that we will be covering the entire geography in the theme-wise manner. If suppose you are picking up a textbook, you need not read the textbook from cover to cover. Rather, what you are supposed to do is you have to study smartly, and this is one way to deal this subject in a smarter manner. Our today's topic that we will be taking up is the internal structure of the earth. That means we'll try to understand what is there within the interior of the earth and what are the evidences that we have, as well as how are we going to apply these topics to the various kinds of landforms and the day-to-day life. Right? So for this, what are you supposed to do? You go to class 7, there is a chapter number 2 by the name Inside of Our Earth, and also class 11, chapter number 3, that is Interior of the Earth. Now these are the two chapters that deal with the interior of the earth. Now let me also show you what are these chapters. Look here, this is one chapter. It is the inside of the earth, and in this chapter very basics are given in class 7. What are the various layers that you have, as well as the various dimensions of the interior of the earth. So this is a very basic overview was given in class 7, and you can also go and look into the class 11. In the class 11 NCERT also little more detail and in a technical manner it has been written, but it is not that easy for you to understand if you go and read it. Rather, you definitely need a very good quality of explanation to understand this particular topic. So without wasting much of our time, we'll directly jump into the topic itself. So this is one chapter, you can give a reading after some time, right? Okay, now in an overview, I wanted to tell you what are we going to discuss. See, we are going to discuss what are the layers that are present within the interior of the earth and how did we get to know. You know that the interior of the earth has core, it also has mantle, it also has crust, as well as other various layers which are broadly divided on the basis of chemical composition and also on the basis of mechanical composition. Your chemical composition is different from that of the mechanical composition, and the interior of the earth, it rises, it spreads out in either directions, and then it also makes certain kinds of landforms on the surface of the earth. So we'll try to understand how is it being done, right? So I'll give you a very lucid and detailed explanation, and if you have any doubts, you can also get in touch with me as well, right? Okay, let's quickly begin. See, firstly, I have a fundamental question. See, the deepest mine that we have ever dug is not more than 15 kilometers. Okay? But how did you get to know about that there is a core at a depth of near about 6,000 kilometers? So what are the techniques that you have used? Did you ever dive deep into there? No. That means there are some technologies that you have used. Now what are those technologies? See, let's try to understand what are the sources of the interior of the earth. See, the sources of the interior of the earth, first one is mining. You go and do the mining, and the deepest mine that we have ever dug is not more than 15 kilometers, which is done in the Kola Peninsula at Russia, right? This is one source. The second source is the drilling, deep ocean drilling. Suppose you go onto the oceans, and if suppose this is a continent, you can drill here also. You can also go into the depths of the ocean and you can drill. So easily you can reach little more depths of the interior of the earth. So that is drilling projects, which is also the deep ocean drilling projects can also be considered. Now other direct sources are nothing but your volcanoes. Volcanoes throw out certain kinds of material from the interior of the earth, and because of that we get some rocks, and we'll study to understand those rocks. When you study those rocks, you will get to know that this rock might have come from this depth and this is the composition of the rock, and based on this understanding we will be coming to some kind of conclusions that this rock might have come from X depth and this is the material that is found. But our direct sources are very limited. Human cannot explore beyond a capacity into these sources. So that's why we went into indirect sources. Now what are these indirect sources? Number one, it is your gravitation. See, our earth is a geoid shape. In the last class we got to know. That means from the center, the gravity experienced at the equator is less as compared to the gravity experienced at the poles. That means this fellow experiences more gravity and this fellow experiences less gravity. So gravitation gave one or the other understanding about the interior of the earth, right? Next is magnetic field. I'll explain about the magnetic field in some time, but the most important source is the seismic activity. Now what do you mean by seismic activity? It is about the vigorous shaking of the earth, which we also call it as an earthquake. Okay? Because of this earthquake, we got to know that what are the layers which are present in the interior of the earth. So to understand the interior of the earth, you also need to study the seismic activity in a detailed manner. See, whenever there is a seismic activity, whenever there is an earthquake means it is the vigorous shaking of the earth, and this will lead to the release of waves. Earth will release certain kinds of waves, and these waves are of two different types. One, it releases body waves, and it is also releases surface waves. But what actually is a wave? Can you tell me what is a wave? You might have been to beaches. There also you will have wave, right? You might have heard about sound wave. Sound travels in the form of wave. Vigorous shaking of the earth is also releasing waves. See, in simple terms, a wave is nothing but transfer of energy. Wave does transfer of energy. You can also note it down, take a pen and a paper and jot down, so it becomes easy for you. See, wave means transfer of energy, and in simple terms, if I am speaking from here and maybe a person might be sitting 20 to 30 feet away from me, if that person is able to hear, it is because there is a wave called sound wave which moved from my voice box and then it traveled to his eardrum, and it shaken the eardrum with the same frequency the way I spoke. That means I have transferred the energy from my place to that particular place. Now this is called as a wave. Wave always transfers the energy from one place to another place, right? This is called a wave. Wave nature, the work of a wave is always to transfer the energy. So likewise, whenever there is an earthquake always releases certain kinds of waves. That means energy is released, and that energy is transferred in an irregular manner through two types of waves. One is body waves and other is surface waves. Now further, these body waves are of two different types. That is earthquake waves, that is P waves, and you can also have S waves. Okay. P waves means they are primary waves. S waves means these are secondary waves, right? Now these two are very unique waves. The characteristics of P waves are different from the characteristics of the S waves. Because of these characters, we are able to understand what kind of layers do you have within the interior of the earth. I'll explain this in the next 10 to 15 minutes, how these waves helped us to understand. Even we, without going into the depths of the interior of the earth, we got to know about what is the layers that we have, right? Now these waves are studied extensively in the laboratories, scientific laboratories, and we got to know that there are some characteristics. That characteristics, if you know and apply them to the interior of the earth, you will also understand the interior of the earth, right? So if you have any doubts, you can also come and contact me. I'll be very happy to resolve all your doubts, but please be patient to watch this particular class at a go. Do not spend too much of time going here and there. Stick to this particular class. The concept that you're going to get is going to be very phenomenal for your examination, because every year at least one question is asked from this particular area in the examination. Okay. You got to learn that there are two different types of waves. One is body wave and the other surface wave. Body waves has P waves and S waves. P waves are primary waves, S waves are secondary waves. P waves, they can travel through solid, liquid and gases. S wave, they can only travel through solid. How do I know? Because scientists have studied them in the laboratories, right? Now surface waves, these are very unique waves. Okay, I'll talk about the surface waves. The type of surface waves, they are also called as R waves, L waves. R is relay waves, L is love waves. Okay, these are also very dangerous. Now what do you mean by body and what do you mean by surface? See, our earth has two different types of entity. That is, our earth, look at this particular diagram, you will get to know that. See, if you look at this, this is called as the surface. Okay? This is called as the surface. And you go deep into the interior of the earth is called as body. Right? I hope you are clear with this. What is surface? Surface is on the surface, that is on the top layer of the earth. This is called as surface. Now what is body? The interior. That means whenever there is an earthquake that is generated, first waves travel through the body of the earth, and these, as soon as they come near to the surface, a new set of waves are generated. They are called as surface waves, like this. That means, look here, I'll play the video again, and through this video you can have a better understanding. Suppose you look, let's imagine that there was an earthquake which generated at this depths. Right? From here the earthquake started. Now as and when the earthquake is traveling through the interior of the earth, okay, it can travel in all the directions like this. It can travel in every direction the way in which it goes. Likewise, until and unless this earthquake wave is traveling within the body, we will call this as body wave. Right? Now once this earthquake wave reached onto the surface, let's say that as soon as it reached the surface, it will travel on the surface like this. It will travel on the surface. Now these are called as surface waves. Now these surface waves are of how many types? They are also of two types. One is R wave and the other is L wave. Body waves are of two types, that is P wave and the other is S wave. P wave is called as primary wave, S wave is called as secondary wave. And I already told you P waves can travel through, they can travel through solid, they can travel through liquid, they can travel through gases. How do I know? Because we studied it in laboratory. And S wave, it is also traveling, it can only travel in solid. Or एक और characteristic, one more characteristic is that, see, as and when this particular P wave travels through a more density material, the speed of this wave also increases. How do I know? Again, laboratory studies. Right? Scientific community tried to understand this, and in the laboratory we got to learn that even this, as the P wave is passing through any kind of higher denser medium, higher denser material, the wave velocity also increased and the speed of the wave also increased. Right? Same goes with S wave also. But S wave, as soon as it touched the liquid, it got dead. Right? By using these two characteristics, we got to learn about what is there within the interior of the earth. Now, are you clear? The fundamentals and the basics that we are going to study? Yes. Okay. With this, we should also have little more knowledge about what is an earthquake as well. Okay. First, we'll learn something about earthquakes and then we'll move little more further. See, earthquake means it is the release of energy along a fault line. Our earth is made up of n number of pieces. And our earth pieces, they keep on shaking because of various reasons. I'll tell you that in the further classes. So here, earthquake means it is the release of energy at a fault. Likewise, rock layers along the fault, they tend to move. Basically, our earth has certain kinds of layers and our earth moves every now and then because of various convectional cells. I'll explain about the convectional cells in the further classes. Just imagine that our earth has continuous movement. Now, whenever this movement is intense, it will lead to the earthquake. Now, look here, an earthquake can be generated at shallow depths. It can also be generated at deeper depths. An earthquake which is generated at the shallow depths, it is called as the shallow earthquake. Shallow depths means at a lower depth. And an earthquake which is located at the deeper depths, that is called as deep earthquakes. Now, which is more dangerous? Is it shallow earthquake more dangerous or the deeper earthquakes more dangerous? You comment in the comment section, or you do let me know on this particular contact number. Right? And my name is Madhusudan Reddy. Right? So, is the earthquake, shallow earthquakes dangerous or deep earthquakes dangerous? See, the answer is very simple. The earthquakes which are located at the shallow depths, they are more dangerous, and an earthquake which is located at the deeper depths, it is not much dangerous. right? So where do you find these shallow earthquakes? Shallow earthquakes are usually found across the coastlines of Japan and wherever you find the faults, right? See, earthquake is always, most of the times, is generated within the interior of the earth. The place where the earthquake is generated, imagine this is the piece of earth, and let's try to understand. Imagine that the earthquake is generated at this particular place. Now earthquake means it is the release of energy. The release of energy is called as earthquake. Now this place is called as focus या hypocenter. ठीक है? Now the nearest point to the focus is called as an epicenter. Always the nearest point is exactly perpendicular to the focus. Now epicenter is the place where the receiving of the highest energy takes place. Now here the energy is released, right? Now these waves, the body waves come and reach this particular place, and this is the place which will receive first, and this is the place where the surface waves tend to move outward. Now these surface waves, they travel on the surface, and these surface waves create lot of destruction. Okay? They create lot of destruction. That means here you got to see body waves, and here you got to see surface waves, right? See, most of the damage that is caused is usually done by the surface waves. Of course, I don't say that body waves are good, body waves are not dangerous. Body waves, to compare to surface waves, they are not so dangerous. Clear? That means now you have learned what is a focus, what is an epicenter. Focus is also called as hypocenter, right? Epicenter is the place where the first release of energy of the earthquake is reached onto the surface, and that is the place where you will find highest damage, right? Clear? Now for this, I wanted to show you a small video which will help you to understand the topic in a little more detail, right? I think now you are little clear with the concept of the earthquake. See here, let me show you. Look at this. This is the focus. The earthquake, whenever is generated, it will release two set of waves. What are these two set of waves? One is P wave and S wave. P wave characteristic is that P wave travels faster, S waves travel slower. P wave reaches to the surface faster and S waves travel little slower. P wave can pass through solid, liquid and gases. Let me also write it here. You can also at the end make a small box. P wave, this can pass through solid, liquid या gas. S wave, it can only pass through solid, liquid and gases. It cannot pass through, right? And faster it travels slower, right? These are some of the characteristics. Now see, when you know that P waves travel faster and S waves travel slower, why can't you detect P waves and tell everyone that, yaar, there is going to be an earthquake, so everyone move out from your homes? It can be done, right? Then why is the government not doing? Why is the scientific community not doing? It is because, see, the time gap between the P waves and S waves is that P waves travel faster and then comes the S wave. But P waves and S waves, the time gap is not more than a second or 1 or 2 seconds. That is the maximum time. So imagine that there is an earthquake at this particular place. Now the first set of waves that are generated are called as P waves. Now these P waves, they are spread out. Okay? Let's imagine this orange color waves, these waves are called as P waves. And after a second or so, after a time lag, you will come up with the S waves. These are your S waves, right? So imagine that you have water. Imagine that you have water here. Okay, let's imagine. Can your P waves pass through this? Yes, your P waves will pass and it can reach this particular place. But what about the S wave? The S wave, can they pass through the liquid? No, they cannot pass through the liquid. So that's why these S waves, as soon as they come and reach the liquid, they are dead. Right? Now like this, we got to know that, yaar, wherever there is water, their S waves are not going to come there. That means scientists have identified that, yes, this layer might have been liquid. That is the reason why if there is a seismograph that is placed here, if suppose there is a seismograph or any meter that is placed, for this they got to receive S waves, but they got to receive P waves, but they failed to receive S waves. S waves are not received to this particular area. Now it is an indication that maybe in some part of the interior of the earth there might have been a liquid layer. Now this is how the scientific community have tried to understand what do we have within the interior of the earth. Okay, coming back. Now if we have a technology of this kind, that this is a P wave, as soon as the P wave comes and hits the surface of the earth, imagine that we can generate alarms, we can generate some kind of emergency sirens where everyone can save their life. Wouldn't it be fantabulous? It can save a lot of economy. Emergency services can be stopped, such as nuclear power plant is there. Can you switch off that nuclear power plant to automated machines? You can do it. So currently the government is working on these type of technologies, but as of now we do not have this technology on the ground, right? So this is how you need to interlink the current affairs with that of the static, right? So this place is called as, what is this place called as? The place where earthquake is generated, it is called as, this is the hypocenter, or it is also called as focus, and this will start to release P waves followed by the second set of waves, S waves, and the place where the P waves reach to the surface of the earth for the first time, this is called as epicenter. And at this epicenter we measure what is the earthquake, how much is the magnitude of the earthquake, is it 5, 6, 7.5, 7.8, 10, 9, 7, 6. This is how the earthquake magnitude is checked, right? This is the fundamentals of the earthquake, right? I hope you got this. कोई doubt है यहाँ पर? Or now this type of diagrams are also there in your NCERT. ठीक है? How to understand this diagram? Imagine that there is an earthquake. This earthquake started to come. The first set of waves that you will receive is called as P waves. उसके बाद कौन सा waves आएगा? After this, the next waves are called as S waves. Now after the S waves you will find surface waves. Look, the surface waves are little more dangerous. The duration of the surface waves is way bigger. Look at this graph. They are very small waves, but look at the amplitude of this. Amplitude is the vigorous shaking of that, right? Now you also need to know the characteristics in little more detail. See, S wave is also called as transverse wave, and it is also called as longitudinal wave. Now what is a longitudinal wave? What is a transverse wave? Let me try to tell you. Once you know about this characteristic, then we'll go and try to understand which earthquake are dangerous and which waves are not dangerous. See here, every wave has its own direction. ठीक है? Imagine that I have created a wave here. Imagine this person created a wave, and there is another person who is standing here. Look, the wave can travel in this direction, right? I am talking about direction. Don't get confused with the concept of direction as well as the propagation. See, if suppose I am sending a wave, if this is person A and this is person B, the person A is sending a wave, while the person A sent the wave went to B. What is the direction of the wave? If suppose this is north, this is south, this is east, this is west. Suppose this person is sending the wave towards the person B, the wave direction is in the forward direction, right? The direction of the wave is A to B. Now, what do you mean by propagation here? You also need to understand the concept of propagation, right? So, look here, wave direction is in this format. Can I draw it like this? A to B. Now here you also need to learn the concept of propagation. Every wave has a direction and every wave also has a propagation. Direction and propagation can be in the same direction, same side, or same angle, or sometimes the direction and propagation can be in transverse way. Suppose, what is a longitudinal wave? A longitudinal wave is something where the direction, a longitudinal wave is a wave where the direction of the wave is parallel to the propagation. Where the direction of the wave is parallel to the propagation, that is called as longitudinal wave. That means your P waves, they travel like this. Let me show you how your P waves travel. Look, imagine this is person A who is trying to send waves to person B, right? What will be the direction of the wave? The direction of the wave is A to B, right? Now, if suppose, imagine this is a box and this box has certain particles. Okay. Now, person A has sent a wave from A to B. What is the direction of the wave? The direction of the wave is from A to B. This is direction. What is the propagation? Propagation means how does the particles move? Are they moving parallel to the direction or are they moving perpendicular to the direction? If suppose, if this is a particle, let me exaggerate this particle. If suppose this is a particle and this particle, if it is moving in the forward backward direction, that means A to B is the direction, and the movement of this particle, if it is moving forward and backward, this is also called as parallel propagation. Okay? That means if A to B is the movement of the direction of the wave, then if the particle propagation is also in the same direction, this is called as parallel propagation. Right? Right? Are you clear with this? Please try to understand. Now let me show you how your P waves have the characteristics. Imagine that there is a wave sent from here to here, right? The propagation of the particles are also in the same direction. Now this is called as a longitudinal wave. But look at a transverse wave. The transverse wave, while the wave is moving, the particles will move perpendicular in nature. Look, come to the S wave. S wave is transverse wave, right? That means if suppose, I know this will take little time for you to understand, but once you understand, you'll give me little smiles. The conceptual clarity will be quite clear for you. So try to understand this. A has sent a wave to B, and imagine these waves pass through certain particles. Maybe imagine that I am sending a wave through this. Now how does the particles in this particular keyboard moves? Here direction is in this way. Now propagation, here the propagation of the particles will also be in the same direction. It is like this. The propagation will also be in the same direction. So that's why we call it as parallel. Are they parallel? Yes, they are parallel. But when it comes to transverse wave, it is not like that. See, if A to B is the wave that is sent, and imagine the same wave is moving now through a solid material. Now the particles in that material, if suppose these are the particles, now the particles in this material, they don't move forward and backward. Rather, this particle will move in this direction. Okay? Let me show you again. If suppose this is a transverse wave, imagine this is a transverse wave. Whenever transverse wave is sent, this wave, see, if you are sending a wave in this direction, the particles in this particular body will start to move like this. Wave direction is this. Particles are moving perpendicular to my hand, right? So this is called as a transverse wave. In the transverse wave, the particle movement and the direction of the wave, they are perpendicular to each other. That means this direction is in this side, whereas propagation is perpendicular, right? So those propagations which are not parallel, they will be very dangerous to the earthquake. They will be very dangerous to the any construction. Now just simply imagine that you have a house. Let's imagine that you have a house. Let me show you. Imagine that, just give me a minute. You will yourself tell me in the next 1 minute that which waves are more dangerous and why. See, let's imagine that this is India, right? So let me construct a house here. Okay, let's imagine I have constructed a house, or for our simpler understanding, I will tilt the earth. Let's imagine that there is a house that is constructed, right? If suppose here you have an earthquake, and I'll call this as the hypocenter, and from here the earthquake came and it reached epicenter. Now you tell me, are P waves dangerous or S waves dangerous by using the propagation of the waves? P waves, they are parallel to the direction of the wave. S waves are perpendicular to the direction of the propagation of the wave. So first let's understand that this is a P wave, right? P wave comes, P wave passed like this. Okay. What is the direction? Direction is from A to B. Imagine this is your house. How does the particles move in the house? The particles in the house will move north and south. It is like this. Just a minute. Imagine there's an earthquake and this is your house, or not your, any of the house, right? Now see, I've sent an earthquake wave, and this earthquake wave, P wave, which can travel through solid, liquid and gases, right? Now this wave has reached near to the surface, and how does the particles in the house move? The particles in the house will also move up and down. Okay. Now let me put some pillars to this house. See, let me put some pillars to this house. Right. See here. That means whenever P wave is moving, your house will move up and down like this. That means your house will move like this. Right. Now let's imagine S waves are trying to move through your house or any building. How does the building moves? The building will move like this. Let's try to understand. Imagine this is someone's house, right? If suppose I am moving the S waves, imagine this is an S wave. S wave, while it is moving, what is the direction? Direction, imagine this is A, this is B. The direction is A to B. Now particles in the any house or in any solid body, how does the particles move? Do they move up and down, or do they move sidewards? See, in the S waves, the particle propagation is perpendicular. So that's why your house will now move like this, right? What is the direction of the wave? Direction of the wave is like this. How does the particles move in the S wave? The particles will move. Imagine this is a particle. The particle will move perpendicular, right? So that means this is how the particle moves. But in the P waves, this is the direction of the wave and the particles will move. Imagine this is the particle. The particle will also move up and down like this. So the highest damage is going to be caused by S waves. You cannot have a house moving side waves. You shake it like this or you shake it like this. Usually in this shaking the damage will be more because the pillars can also get damaged, right? This is the fundamental difference of earthquake, of P waves and S waves. Now come to the other set of waves. I also told you in the beginning that you also have P waves, S waves, right? Apart from that, you also have some other type of waves. In the beginning, I already told you that earthquake has two types of waves. One is P waves, S waves, which are also called as body waves. Now these are your body waves. right? You also have surface waves. Now what are these surface waves? Surface waves are R waves and L waves. Now the propagation of these R waves and L waves, they are way different as compared to the propagation of the P and S waves. These are very notorious. These are very dangerous. Now let's try to understand them. Look here. Look at this. When P waves comes and hit the surface, this is the kind of damage. But S waves, this is the kind of damage. But L waves and R waves, dekho, these waves are very dangerous. L waves means love waves, R waves means relay waves. These two are surface. And this is body waves. Right? One is body and other is surface. Now surface waves are way more dangerous, and which is more dangerous? It is this love waves which are way more dangerous as compared to any other waves. Okay, for our understanding, we have used body waves and the body waves to understand the interior of the earth. Now you already know the characteristics, that what are the different set of waves that are present, and their characteristics also you know. We will not be going too much into detail to understand the surface waves R and L waves. R and L waves will create a damage to the interior of the earth, no doubt, and exterior of the earth, there's no doubt. But body waves, we have used them to understand the layers of the earth. Look at the characteristics. Again, let me remind you, it can pass through solid, liquid, gases, and the velocity or the speed increases as soon as it moves to higher density material, right? The velocity increases as we move to the higher density material. Now with these characteristics, we were able to identify what kind of layers do you have, right? Now let's try to go and understand these particular parameters. Number one, see, whenever there is an earthquake that is generated, your earthquake will not just keep it to itself. Your earthquake, if suppose there's an earthquake which is generated around 5 kilometers into the interior of the earth, okay, the earthquake will start to move in every direction. If suppose this is an earthquake, this earthquake will also move in every direction. The body waves will move to the opposite side of the earth also. Every direction it will try to move. Now, scientists across the globe, what did they do is they have placed the seismographs at every place. Now, what is a seismograph? Seismograph is a device which will identify if there is any earthquake that is there. So, across the globe, we have placed this. And to our surprising, whenever there is an earthquake, it takes place on the earth, few places on the earth did not receive those earthquake waves. And the scientific community was worried, why did these earthquakes did not receive? It is because that means if suppose P waves received to this area, you tell me P waves have received to this area and S waves were absent. If P waves were present here and S waves were absent here, what does that indicate? What does this indicate? If P waves are present in this part of the layer and S waves are present and absent in that layer, it's an indication that maybe somewhere here there could have been a liquid or a liquid layer, right? And this liquid layer, imagine these are your P waves, they have passed, and these P waves also, whenever they are moving through a liquid layer, they always change their direction. Now let's imagine that there is an entirely a liquid layer within the interior of the earth. Okay? Imagine this is a liquid layer, and if there is an earthquake which is generated at this point, this is a P wave, it can pass, P wave can pass, P wave can here also pass, P wave can also pass. But what about the S wave? Let's imagine this red blue color is the S wave. Now S waves, they will be recorded here. S wave is recorded in this seismograph. But what about the S wave? As soon as it touches this liquid, your S wave is dead. That means this entire area did not receive S waves. So using this concept, we have tried to understand that the earth is having various layers. So the scientific community have worked upon this, and we got to know that there are some shadow zones. Now look at this. there are some shadow zones. Now what are these shadow zones? These shadow zones are none other than the places where the waves were absent. Right? I told you that the entire earth is now covered with the seismographs. You have these seismographs. Seismographs will note down the waves that have been generated. Now these waves, this part of the area of the earth, if there's an earthquake that is generated here, that means these waves, especially P waves, were absent in this zone. But look at this, S waves were absent from here to here. Why? It is because, let me try to show you. Try to watch this. Imagine these are P waves. Whenever there's an earthquake that is generated, the earthquake moves across the earth in all the directions. Now we got to learn that there is a liquid layer within the interior of the earth, and this liquid layer will not let the S waves pass through, but it will let the P waves pass through. And one more interesting fact here is that as the P wave passes from a solid layer to a liquid layer, their waves bend, their direction change. That means any wave, when it is moving from a high density material to a lower density material, or a lower density material to a higher density material, maybe from water to a solid, solid to a water, the direction will be deflected to an extent. So that is the reason why we got to learn that our earth is having an interior layer which is made up of solid, and which we call it as inner core, and there is also another layer which is made up of liquid. That means P waves were able to pass through this, but as soon as the S wave comes, it is being blocked because we matched with the entire seismographs across the earth. Now try to watch this. This is your P waves. Okay, let's try to watch it. These are your P waves which are passing through all the layers in the interior of the earth, right? But the direction of the P waves can also get changed because of the density differentiation is there within the interior. Maybe there is a liquid layer, there is a solid layer. Till now I did not tell you what are the layers, names of the layers. I'll tell in the next few minutes, but be patient. Now this red color is the place where the absence of, you got to see, there is no, in this seismographs, you did not get to see the recording of P waves. Why? Because P wave might have reached here and there might have been a layer which is having a different density, so the waves bent, right? So with this we got to know that interior of the earth there might be a differences in density. Now watch the S waves. These are your S waves. You will be very surprised to see that these S waves, as soon as they reach a liquid layer, they are blocked, right? This is a liquid layer that is completely blocked. That means the seismographs which are placed on the earth, they don't recognize. Now look at the length of these S waves which are generated from the same earthquake, and the absence of these recording on the seismographs. That means your S wave has a more wider shadow zone as compared to your P wave, right? P wave has less shadow zone, S wave has more shadow zone, right? Now look at this. With this we got to know that there could have been a layer which is made up of liquid, and there could have been a layer which is made up of solid here. Now this is your solid, and this we call it as inner core, and this layer which is also called as the outer core. Our outer core is liquid in nature, and our inner core, it is solid in nature. How did we get to know that outer core is liquid and inner core is solid? Because P wave passed through them and S waves did not pass through them. That's why we have declared that there is an outer core which is made up of liquid. But again, you see a P wave, when it is passing, it has changed its direction, again it's changed its direction, again it changed its direction. So these changes in the direction has led to the conclusions that our earth is having various layers, and these various layers are none other than divided into core, which is inner core and outer core, mantle, which is further divided into multiple layers. In the lower mantle, intermediate mantle, upper mantle, and then you also have furthermore layers on the surface which we call it as crust, right? So this is what is the layers of the interior of the earth. Now I hope you are clear with this particular concept, and if you have any doubts on this topic, I know you will be definitely having few doubts, so you can also drop a message to understand what do you mean by. If you have any doubts on this particular topic, you can also drop a message to me. I'll be very happy to address your doubts as well. Okay, I hope you are clear with this, right? Oh, done. Now let us go a little more further. Okay, you also got to learn what are the various layers, but we need to understand what kind of layers do you have within the interior of the earth. See, your earth has multiple layers, and these multiple layers are divided into multiple densities. See, just a minute. When I take a piece of earth means, if suppose I've taken this earth, right, and imagine this is your earth. What I'll do is, usually in your textbooks, this piece of earth is taken, okay, and they try to study this. That means, what are the layers, at what depth, what kind of layers do you have, right? We will also do the same because books are also written in that manner. So to make it little more understanding, I've drawn this diagram. Come back. Our earth can be further divided into two different types of differentiation. One on the basis of chemical composition of the earth, and the two on the basis of the mechanical composition of the earth. So what I'll do is, I'll divide this earth into two different compositions. What is the interior of the earth is made up of? One on the basis of the chemical composition, and the other on the basis of the mechanical composition. Now chemical composition means at what layer, what kind of depth, at what layer, what kind of material is present. Is it lithium? Is it nickel, ferrous, aluminium, silica? What kind of material? On that material basis, I have divided on the base. I've divided the earth onto chemical differentiation, और chemical basis के ऊपर मैंने earth को divide किया. Likewise, on the basis of mechanical means, is this layer solid? Is this layer liquid? Is this layer semi-molten, plastic? So broadly, your earth can be divided into two types. On the basis of chemical composition, let me show you a small size. See, your earth can be divided into chemical number one, crust. Okay? That means this will be your crust. Then you will have mantle, and this mantle is further divided into upper mantle. It can also be divided into the lower mantle. Then you have outer core and inner core. Now this is what is your chemical composition. One, on the surface you have your crust, then you have your mantle. This mantle is further divided into upper mantle and lower mantle, and then you have core. This core is further divided into outer core and inner core, right? In simple terms, if I take up the diagram, it is going to be like this. Crust, this is your crust, and then you will have the mantle, and this mantle, this is upper mantle, and this is lower mantle. You can also divide this into intermediate mantle as well, right? Further, you have a core. This is your core, and this core, this is outer core, which is liquid in nature, and this is inner core, solid in nature, right? So this is the only layer which is liquid in nature. Now this is called as chemical composition of the interior of the earth. Now how did I get to know that this is liquid? Simple AR. What have you done is, when there was an earthquake which was generated here, this earthquake waves which were moving, you calculated the densities, you calculated the speed, you calculated the movements in various different ways. And that is how you got to know that these are the layers. Now, as we go into the depths of the interior of the earth, an interesting aspect is that first, let's try to understand what is crust. Your crust is made up of primarily, this is your crust, right? This is made up of Cl, that is silica plus aluminium. Mostly silica and aluminium is found in here in one or the other form, and the density of this particular crust is very low. Okay? Volume of this particular layer is very less. The density is 2.7 grams per cubic meter. Right? This is the density. Clear? And the thickness of the crust varies in the range from 5 to 30 kilometers and in the oceans, and 50 to 70 kilometers in the continent. That means, look here, this crust can be further, I can show this crust like, look here, the crust can be of two forms. Our earth can have oceans and our earth can have continent also. Imagine this is your continent and imagine that is your ocean. The thickness of the crust of the ocean is hardly 5 kilometers to 7 kilometers. Whereas you imagine this to be a continent, the thickness of the crust can go up to 70 kilometers. Especially you go to Himalayas, the crust thickness is almost up to 70 kilometers. Now that is a very, very great thickness. Likewise, you see, once you have the basic understanding of the crust, just give me a minute. The oceanic crust is made up of basalt and the continental crust is made up of silicates, right? Are you clear with this crust? Okay. See here. What I'll do is, I'll create a mountain. Likewise, now I'll create an ocean. That means this thickness is hardly 5 kilometers and this thickness, it can go up to 70 kilometers. Right? Now, upper mantle, lower mantle and intermediate mantle. Look here, your crust is made up of silica plus aluminium, whereas your mantle is made up of SEMA, silica plus magnesium. Okay? Whereas your core is made up of knife. What is knife? Nickel plus ferrous. Knife means nickel plus ferrous. SEMA means silica plus magnesium. Cl means silica plus aluminium. Now this is the chemical composition of the interior of the earth. And one more thing, as you go into the interior of the earth, you will learn that every layer as we go down, their density is increasing. Okay? The materials are more denser as compared to the layer above. That means the material which is found in the mantle is going to have higher density as compared to the material which is found in the crust. And when you come into the advanced classes, I'll be teaching you in a very beautiful manner about each and every layer, slicing it down with respect to UPSC examination. So I'd also be very happy if you can also come on to the advanced classes where we will be teaching you in a very detailed manner about these layers. At the NCERT level, I think this is the basic understanding that you need to have, right? That is Cl, SEMA and knife, which is the upper crust, and crust can be of continental crust and oceanic crust. Your oceanic crust is made up of basalt. Your continental crust is made up of granite. Your continental crust is made up of granite. Oceanic crust is made up of basalt. And this is made up of SEMA, silica plus magnesium. And this is made up of knife. And the outer core is liquid, inner core is solid. Now this is the chemical composition. But more than chemical composition, the most important aspect is the mechanical composition. See, in the mechanical composition, the divisions are different. The mechanical composition, you will have crust. Okay? This crust is nothing but your lithosphere. Now what is lithosphere? Lithosphere, then you have asthenosphere. then you have barysphere, or which is also called as mantle. ठीक है, within this mantle, upper mantle and lower mantle, then you have outer core, and then you have inner core. In both the aspects of mechanical and chemical composition, one thing is common, that is outer core is liquid. Your outer core is liquid. Now this is the mechanical composition. The only difference between the chemical composition and mechanical composition is that your chemical composition takes into account, is it silica, is it aluminium, is it magnesium, but your mechanical composition looks into, अरे यार ये solid है, ये liquid है, is this a solid or is this a liquid? Now you know that there is one layer which is liquid, outer core. There is also another layer called asthenosphere. This is neither liquid nor solid. It is a molten plastic. It is neither liquid nor solid. It is a molten plastic. What is this molten plastic? In simple terms, if you put too much weight onto the asthenosphere, you will realize that your asthenosphere will start to sink. Okay? Your asthenosphere will start to sink. Your asthenosphere layer will be like this. Imagine this is the asthenosphere layer, and above that you have a lithosphere layer. Just imagine this is a lithosphere layer. On the lithosphere you can also find some oceans. Imagine this is an ocean. Okay? Just imagine this is an ocean, and you put some mountains over here. Imagine these are Himalayas. So what happens to the asthenosphere is that very surprisingly your lithosphere will start to sink bottom, and your asthenosphere will also shape out. Your asthenosphere will be shaped out like this. It is just like a pillow. You put a head onto your pillow. What does the pillow do? Pillow will have a saucer shape. Your head shape will be there on your pillow, right? Likewise, your asthenosphere is also like a pillow. You put too much weight, it sinks. It changes its shape because it is not solid here. It is semi-molten in nature, right? It can be punctured easily. If there is too much of heat, it will be punctured. Now this is the mechanical composition. In this mechanical composition, let me first show you what are the layers. One is lithosphere. Okay? One is the lithosphere. Then followed by asthenosphere. You will also have mesospheric mantle, that is also called as barysphere. 3 layers, outer core and inner core. Right? Yes? Any doubts here? Chemical composition dekho, crust, upper mantle, lower mantle, outer core, inner core. Very simple. But in the mechanical composition, lithosphere, then you have little lower asthenosphere, then you have mantle, which is also called as mesospheric mantle, but part of the Earth's mantle below the lithosphere. This is completely different. So here, if you come across this particular lithosphere can be punctured. Okay? If you put too much heavy weight onto the lithosphere can get punctured and the volcanoes can start to come up. Usually, the older oceanic floor becomes more denser, and that is the reason why your asthenosphere punctures and it enters into. And in the advanced classes, I'll explain you in a very detailed manner, as this is written only at the level of the NCERTs. So don't worry. Those who are going to be in the advanced classes, for them, you are going to enjoy these particular topics in a little more detailed manner. Right? Any doubts still here? You can always contact me. I'll be very happy to address all of your doubts. Right? Okay. Let's try to look into the characteristics of the lithosphere. Look here. The characteristics of the lithosphere is a very rigid outer layer, right? And the thickness of the lithosphere can go up to 200 kilometers. Look here. It can go up to 200 kilometers. On the oceans, it is going to be little less, but on the continents, it can go up to 200 kilometers, right? Now, this lithosphere includes, when I am comparing the chemical composition with that of the mechanical composition of the interior of the earth, your chemical composition has upper mantle, lower mantle, above this you have crust, right? This here you have lithosphere. This lithosphere consists of crust plus upper part of the upper mantle. These two together you will call it as lithosphere, right? I know you will get little confused, so that's why I'll be showing you here what is lithosphere. Your lithosphere means this part of the layer, upper part of the upper mantle. Some part of the upper mantle you take and this becomes lithosphere, right? Now what is asthenosphere? When you compare this with the asthenosphere, the lower part of the upper mantle which is there, the lower part of the upper mantle, this becomes your asthenosphere, and rest of the mantle here, this will be called as mantle in this particular case. That means we have divided the chemical composition with that of the mechanical composition. And let me repeat this again. What is a lithosphere? Lithosphere means crust. One is crust plus upper part of the upper mantle. That means the upper mantle le lo, this becomes the lithosphere. Next, see, the density of this lithosphere is comparatively less, and this entire lithosphere is made up of plates. देखो ये जो lithosphere है ना, just imagine until 200 kilometers depths into the ocean, until 200 kilometers into the depths of the ocean, it is like this. See, imagine this is one piece of earth. This piece is broken up till 200 kilometers depth, that lithosphere, and this lithospheric piece is called as plate. Now this plate can move. ठीक है? In simple terms, this is one plate. This is Indian plate, and this Indian plate up till 200 kilometers depth, it is like a piece of cake, ठीक है, which is floating onto the water or liquid. That is how it is. Now what is that water or what is that liquid? That liquidified solid or plastic molten material जो है ना, that is called asthenosphere. Like this, our entire earth is made into pieces. Each piece is called as a plate, and these pieces are actually called as lithospheric plates. Imagine this is the lithospheric plate. ठीक है? ठीक है? Imagine this is your Himalayas and this is your India. This is floating on an little bottom layer which is called as asthenosphere. ठीक है? This is your asthenosphere. This is how it is. As you go into the depths of the interior of the earth, you will realize that this is how imagine this is India. So this is your lithosphere and this is your asthenosphere. That means this part of the earth is actually floating on the asthenosphere, and this asthenosphere is a layer which is plastic type of material, which is molten plastic, which is neither solid nor liquid. तो एक पिल्लो की तरह होता है this material, and this is how the interior of the earth is there. But the density of this material is more as compared to this material. ठीक है? Always remember, as you go deep into the interior of the earth, the density of these materials are always high, right? Okay, now come to the literature. I'll give you this particular PDF of the literature and these images, so don't worry, you just need to go and understand the basics, rest everything will fall into the place, right? Clear with that? So this is your lithosphere is having some kind of heat as well. Okay, now let's come to the next stages, that is next interior layer, that is your mantle. See, mantle alone forms near about 83% of the total volume of the earth, right? 83% of the total volume of the earth and 67% of the earth mass. You know that if this is your earth, you have crust, mantle, that is, then you have core. 83% is present in this particular layer as the volume and 67% as the earth mass. And mantle is having convectional cells. The material which is there in the mantle, sometimes because of excessive heat, what happens is that the heat here will melt the rocks, and that melted rocks will come out in the form of volcano, right? Okay. This Mohr's discontinuity I'll tell you about little later, right? And depth and all in a diagram I'll tell you. What about the density? The density is 2.9 grams per cubic meter to 3.3 grams per cubic meter. Now what was the lithosphere density? Lithosphere density was 2.2. But here you got to see the density is little more, 3.3. This is more denser, and the more the denser material, that is where the sinking happens. Okay. Okay. Next, another important factor is the density ranges from 3.3 to 5.7 grams in the lower mantle. You take this part of the layer, this is your crust. Imagine this is your crust and this is mantle. The upper mantle has low density and the lower mantle has high density. As you move from 3.3, here the lower density will be 5.7. That means the material, as we go into the depths, the density of the material is also little higher, right? This is what you need to know with respect to the mantle. Now come to the other aspect. See, your mantle also has 45% of oxygen. It also has 23% of silica, and 21% of silica and 23% of magnesium. This is not there in the NCERT, so I'll give this PDF to you. You can also write down. And this is also OSM. OSM materials are there in mantle, right? What will be the temperature? The temperature can go up till 4000 degrees Celsius, also 200 degrees Celsius in the upper body, so later 4000 degrees Celsius in the lower body, right? Apart from that, the material in the mantle will always circulate. It will be continuously circulating. Now, why are they circulating? They are circulating because of various reasons. The material which is there here, it always keeps on moving. Okay? This is the mantle. If you broadly look into, this is your core and this is your lithosphere. This is your mantle. In the mantle, there is always rising that will take place. Watch this. That means these rising materials are because there is too much heat present at the lower part of the mantle or the outer core. That is why they get boiled and the material of the rocks starts to rise and it comes in the form of a volcano. Okay? Come back. See. Apart from that, one more important point that you need to know is the mantle is composed of silicate rocks. That's it. It is made up of sima. Next important aspect is the inner core and the outer core. See, outer core is made up of 80% of the outer core is made up of the knife material. Knife is nickel plus ferrous, and within that, iron is the highest composition. You look here, iron, 80% is made up of iron and some nickel. So these are heavier materials which are present at the bottom of the interior of the earth. Whereas this is liquid. I told you outer core is liquid. Why is it liquid? Because the purest materials are present there and it is experiencing very heavy weight. If it is experiencing such great weights, obviously at that pressure, the material becomes liquid in nature, right? And when you come to the inner core is present from 2900 to 5100 kilometers below the earth's surface. And this particular layer has more pure material. It is also made up of the same, that is knife, nickel plus ferrous material. The nickel composition little increases here, and in totality it is present at a little more lower depths. So that is the reason why you have a better solidified pure material in the form of solid, and the temperature it can withstand is up to 6000 degrees. Right. Now these are some of the important facts. Whereas density, if you take 12.6 grams is the density of the outer core. When you look into the inner core density is little comparatively, it is 12.2 grams. That means the inner core and outer core will have the highest density, right? Now these are some of the basic facts that you are supposed to know with respect to the interior of the earth. Now along with this, I would like to also tell you that the entire lithosphere which is there is made up of complete plates. Look at this. our lithosphere is made up of plates. That means the top layer of the lithosphere is always made up of plates, and these plates, they keep on moving from one place to another place. Imagine this is Africa. Your entire Africa is a plate. This is a plate. Now this Africa, it can move in this direction, it can also move in this direction. Whatever is the direction is dependent upon the material that is rising from the interior of the earth, right? Once you understand the various layers of the interiors of the earth, then the further topics will become little more easier for you, right? Okay. And see, one more concept that I wanted to tell you, though that is not there in the NCERT, but I wanted to give you this, that is the discontinuities. देखो बेटा, discontinuities मतलब basically there are few scientists. See, these scientists, they have studied various layers in the interior of the earth. Now all these discontinuities were based on the composition of, they are based on the composition of mechanical composition or chemical composition. They are based on the composition of chemical composition के ऊपर discontinuities based है. They are not based on the mechanical composition. ठीक है? See, this discontinuities means if suppose there is an earthquake wave and it is passing through various layers. Scientists have found the discontinuity in the speeds. When they found the discontinuities in the speeds, they called, this is the layer, the speed of these waves changed rapidly. So I'll be giving this layer name as discontinuity. So Moho was the person who has identified that there is a discontinuity between the crust, upper crust and the mantle. ठीक है? Moho was the one who has identified the discontinuities between the crust, that is the crust and the mantle, and this is called as Moho's discontinuity. Likewise, there is a person named Conrad. Conrad has identified that within the crust itself there is an upper crust and there is also a lower crust. As the waves of the earthquake started to move little lower into the crust, maybe 100 kilometers lower or 50 kilometers depth, the speed of the waves increased, and he identified that instead of moving at 6 kilometers per hour, now they are moving 6 kilometers per second. They are moving at a greater speed. Now he said that this is not continuous, there is a discontinuity. Discontinuity means there is an increase in the speed, and he said that the discontinuity between Conrad and the Conrad is that between the upper crust and the lower crust. He called this as Conrad's discontinuity. ठीक है? Likewise, Repti, he identified the discontinuities in the speeds of the waves at a depths of upper mantle and lower mantle, and the discontinuity between the upper mantle and the lower mantle will be called as Repti discontinuity. Likewise, mantle and outer core and inner core. Now these discontinuities are also given, only two discontinuities are given in the NCERT. Between lower mantle and outer core, it is Gutenberg who has identified the speeds discontinuities. Lastly, between the outer core and the inner core, the discontinuities are identified by Lehman. Now you tell me, these discontinuities are based on chemical composition or mechanical composition? See, your discontinuities are based on chemical composition. They are not based on mechanical composition. ठीक है? Chemical composition के ऊपर आपका discontinuities based है. They are not based on the discontinuities of, they are not based on what? They are not based on the discontinuities of mechanical composition. ठीक है? Discontinuities are not based on mechanical composition. Always the discontinuities are identified on the chemical composition. Right? Lower crust and upper mantle. Okay, let me write it here. It will be easy for you to. This is lower crust and upper mantle, whereas Repti's discontinuity is upper mantle and lower mantle. Gutenberg's discontinuity is between lower mantle and outer core. Layman's discontinuity is between outer core and inner core. And also the last Conrad's discontinuity is between this Conrad's discontinuity, and this is identified at the end. Actually these discontinuities were identified first, and lastly Conrad upper crust and lower crust. ठीक है, clear? And they are based on chemical compositions. So don't get confused with asthenosphere and all of this. See, the chemical composition के ऊपर discontinuities दिया, but not on the basis of mechanical compositions. So you need not worry. Examiner will not ask you asthenosphere के ऊपर discontinuity था. So the words of lithosphere, asthenosphere, as soon as you find, you mark it wrong, because these discontinuities are based on upper crust, lower crust, upper mantle, intermediate mantle, lower mantle, outer core, inner core. Not like lithosphere और asthenosphere के बीच में कौन सा ऐसा discontinuity है. No one has identified those kind of discontinuities on the basis of mechanical composition, right? Though these things are not there in the NCERT, I have tried to tell you all of these things. Okay. Next, another interesting aspect that I have to tell you is our entire earth is made up of plates. ठीक है? See, you need to understand that the earth is made up of plates. You need not go into very details at the basic level of NCERT. In the NCERT they have written in a very complicated manner, but you need to understand that earth is made up of plates, and these plates are of these types. And these plates, why do they move? Because within the interior of the earth, what happens is that at some places in the interior of the earth, the temperature is more. Let's imagine the temperature in the interior of the earth at this particular place is very high. Let's consider the temperature at this particular place is very high. So what happens is that it will start to melt the rocks above, and slowly these rocks, as they melt, they wanted to rise up. ठीक है? They wanted to rise up. While they rise little higher, they go, and as soon as they reach near the crust, they'll try to spread this crust. It is trying to spread this crust. And this crust which is there, it gets broken. Okay, this is one crust and this is another crust, right? This is one crust and this is another crust. Now let's imagine this is X plate and this is Y plate. That means, look at this, the plate got divided, the earth surface got divided. Likewise, at various places on the surface of the earth, there will be rising material. On the other side, the same material which is rising here will move and sink at this place and comes back. Will rise and moves aside and comes back and sinks here, right? So in this manner, wherever there is rising, the plates get divided. Now what is this plate? This plate is nothing but somewhere the depth is up till 200 kilometers thickness is there and it got broken. This is floating. This plate or this plate is floating over the asthenosphere. Okay? That means lithosphere is floating over the asthenosphere because asthenosphere is semi-molten in nature. Likewise, these plates will keep on moving based on the changes within the interior of the earth, right? Now, where are these changes found? These changes are found at the contact of, imagine this is your outer core, okay? And this is your lower mantle. This is your lower mantle. So the melting will start at this particular place. The rocks will start to melt at the contact of outer core and the lower mantle, and slowly they will rise. And once they rise, they move or spread aside. If they cool down, they come and they come back to the same position. Now this is called as one convectional cell. This is called as convectional cells. ऐसे ही कई सारे convectional cells है within the interior of the earth. Because of this convectional cells, on one side it is rising, on the other side it is sinking. So the plate here which is there will also this particular plate will also sink. Okay? On one side, a new material is coming and rising on the earth as a form of volcano. On the other side, your lithospheric plate will go and sink here, right? Rising and sinking is common, and this is what is the principle of convectional cell. And this principle of convectional cell will lead to the formation of new landforms across the places of the earth, right? At various places like this, you will come across that the interior, at one place you will find subductions, and at another place you will find various kind of subductions. Now lastly, I wanted to tell you what is that, at what depth what layers are found. This is purely factual. Okay? This factual is like this. Look at this. The temperature of the crust can go up to 2000 degrees to 1000 degrees Celsius. And see, lithosphere can go up to a depth of 200 kilometers. Okay? Until 200 kilometers your lithosphere depth can be there. Now your mantle, see, this is your asthenosphere. The temperature of the asthenosphere can be going up to 1600 degrees Celsius and 400 kilometers का depth तक जा सकता है. Beneath that you have upper mantle. Upper mantle depth can go up to 2250 kilometers, and the temperature can go up to 4000 degrees Celsius also. That means as you are increasing the depths, the temperature is also increasing. Likewise, as you are increasing the depths, the density of the material also increases. These are the two different varied entities that you are supposed to know. And you go a little more, around 2180 kilometers, another depth of 2000 more kilometers, you will find the outer core. But in this mantle alone, okay, is 87% volume and 67% of the entire weight of the earth is confined to this part of the region, right? So these are purely factual. UPSC or any state PCS examination, they might ask you a range, but they will not ask you exact temperature, because even the scientific community do not know what is the exact temperature at that particular place, right? I hope you had some clarity on this particular topic. You had some good insights onto this. And if you have any doubts, you can also drop a message. And my name is Madhusudan Reddy. Thank you for giving me this opportunity to teach to you. And stay safe. Please read the NCERTs or the material that we are going to give you. That is more than sufficient for you to address this. The chapters that you are supposed to look into is the chapter number 2, that is inside the earth, and the other chapter is the chapter number 3 of class 11, right? And thank you. I'll be seeing you in the next lecture. Stay safe. If any doubts, you can get to me.